In this lecture, I'm going to talk about uh, a little bit of the brain architecture relating to autism, and I'm going to talk about the build how to build a visual room using visual algebra, and I'm going to talk about a few other bits and pieces. But I want to build on the idea of a room, and it's a kind of like you can imagine in the brain. There's this capability in this theory where the the mind creates a room, and in the room there's a variety of objects, and your vision system sees those objects, does some pattern matching, and then a room is constructed. Then the virtual self, which is the system consciousness part, is placed inside the room, and movement is relative to the virtual self, and the virtual self is positioned inside the person's head. And you might say, of course it is, but there are experiments some people have done where they use goggles where they make people feel they're somewhere else, and it creates some interesting effects in their brain. But uh, for the purposes of this discussion, we assume this virtual self is inside a person's head, behind the eyes, and the room that is constructed is around that person, such as myself speaking here or somebody listening or whatever. So the idea is that there's a visual algebra which is passed into that room, and that visual algebra basically builds the room, and it's a very sophisticated protocol. The rough idea is that you get things like visual algebra create room, create chair, and so on. So we kind of think in terms of a living being having these rooms that one can switch into, and messages flowing through the room and building the reality of the room. So you imagine if you're asleep and you're dreaming, you're in the dream room, and things maybe look very realistic when you're there, but really they're just being created by your subconscious. So that's the core concept. That's the most important thing to really understand. Then I kind of touch upon, you know, the types of algebra we need. Later on, I'll talk about it in more detail. Things like reward, pleasure, goal, euphoria, motor function, compulsion, preservation, mood, emotion, sleep, cognition, visual, audio, vocal, math, logic, reason, language, strategy, and HOS events. But the basic idea there is just to try and come up with a very high level list of message types that will flow through the brain, through the system consciousness, and into these rooms, and some of them will build objects and so on. Later, as I've said already, I'll try and be more precise about what each message type does. Um, I've only here is very high level kind of ideas. I haven't really fleshed them out in too much detail, but basically, the cells with the messages are a Turing machine. Um, the concept of pleasure and pain for an android would have to be sort of a manufactured sensation. So the idea is that in the body, it's some kind of a manufactured sensation that the virtual self feels these feelings. Um, then for reproductive stuff, there's reproductive messaging, and then we get onto the idea of visualization or yoga, and a lot of these techniques involve meditation, and a lot of it is you close your eyes and you imagine yourself somewhere else, and you're moving your virtual self into another room in your mind, and you're building objects, and you're placing things in there which will help you become more at one with yourself. So this is kind of the idea of the yoga with the visualization techniques. It's a general comment on visualization techniques where you're context switching yourself into another room based on breathing and so on. Um, I briefly touch upon the idea of a savant. So this is someone who has incredibly specialized messaging for particular operations. Um, I The psychic idea, if it exists, I say is just some kind of external messaging system where somehow a body can externally message to another location. Uh, then I talk about colostrum, and when a mother feeds her child, they say this is a very important part of the upbringing of a child. And a lot of the idea is that the milk has contains, or the substance contains, messaging, which reprograms the immune system. Uh, in a human being, the DNA builds protein machines. In a machine, that may not be the case, but the idea is that the apps will build machine types of some kind. Uh, if one thinks of hallucinations, we would just vaguely say, or say it's just incorrect messaging sent to the SC. So you often see situations, or delusions, or mental illness is just essentially the wrong messaging going into the brain based on insufficient information. Self control would be one's ability to control the messaging that goes into one's system consciousness. Stress, um, it will cause particular kind of messaging to go through the body based on hormones. And if one is relaxed, one would think that the goal-based architecture has reached the goals. So I say here, with conversation, writing, word, and sounds are converted into a HOS grammar. So this is the mapping idea, where one maps from an internal HOSL to the locale. Um, I briefly touch upon the idea of extremely accurate memory, and this is just where the subject can build rooms based on timers. So one of the most interesting, so I talked about message stories. So one could imagine message stories being stored in a brain with associated timing information. And this is later on I'll talk about the idea of pairing of message types. So when somebody saves messages into the brain, one is using both a timer and a message type. So there are some people who have an amazing ability to be able to tell you, on a day such a thing happened. They might say such and such an event, and they'll say that's a Tuesday on a July or something in such and such a year. So the idea there would be that the message stories stored in the brain have been stored with keys, with message keys or paired message keys that include timing information. Now, one of the more interesting things that needs to be figured out, and it's a really pretty crucial part of the architecture, is timing. And the idea is that an app has to be switched on and off when it's within a certain state. So if an app is in a certain state and it receives a certain message, it could be that it needs to ignore that message for a certain amount of time. So, for example, one can imagine the aging mechanism, where cells age and they go through a life cycle. So they have to stay in a particular message state for a particular period of time before they can move on to the next state. So how's that achieved? So very simply, the idea would be that that the cells or the untyped or untyped actors have some kind of wait state, which is a little bit analogous to like a second or a minute or whatever, but it's a wait. So in other words, don't don't leave this state until so many waits have happened. So in the example I have here, state A has 4 waits, state B has 1, and state C has 8. Now these obviously have to then map to actual other apps and so on. So you can imagine when a person is a lady or whatever person is pregnant, it takes 9 months approximately. So there's a timing issue there. So there's a lot of as certain components or parts of a being are built, other bits have to wait, and there's signaling and scheduling issues there. So when having done a small bit of looking at this, there's not a lot of information on the web about how a cell nucleus has a timer, because to a certain extent it's the holy grail of microbiology, which is, if they can figure out how the timer works, maybe people can like live longer or something. It's not necessarily that simple, but if you look it up, it's not that obvious how it works, and there may be people who know it, but it's not that easy to find information. But the bottom line is, a cell does need to implement some form of a timer, in order to know when to move from one state to another, and so on. Um, and that's the idea of these wait states. So, in very general terms, if we're going to if we're going to implement an Android, we're going to need to implement some kind of wait states in the untyped and typed actors that are going to be generated. Next is a pretty important topic, and it affects a lot of families. And I'm only just going to basically skirt over it. I mean, it's a huge, huge topic, and it affects a lot of families in the world. But it's the topic of autism, and like, why would a thinking machine design need to be concerned about autism? Like, are we going to make autistic androids? No, the answer is to understand what the kind of the theory behind why it happens, and to just watch out for it when in the design of an android. So you try to figure out what the issue is there. So I did a small amount of investigation in it, and the long and the short of it is, no, there is no real consensus on what causes autism. There are some theories around it. Some people think it's to do with certain chemicals. Some people think the child is just born that way or whatever. But I'm not going to say I believe one or the other. But if we take a look at, because I don't know, and it's up to people who do this for a living to decide what the solution is and why it's happening. But basically, the cerebellum. What they have found is that in the cerebellum, which is a part of the brain where where the which develops in children into adulthood, they do find when they do kind of examinations in patients who are say deceased, they find that these areas are underdeveloped. So they don't quite know why. Um, so uh, so basically, it appears there's certain parts of the brain are underdeveloped, and in some cases of autism. I don't quite know why personally, but if one just takes a very I'm not a medical person, but if one just takes a very high level view of it, it looks like the cells that form certain parts of the brain, particularly in the cerebellum, are just underdeveloped. They're immature and they don't seem to develop correctly. So let's just think about that. If we're going to build an android and thinking machine, there are parts of the brain that are going to be responsible for the processing of information, for want of a better word. Whether it's vision or sound or whatever, you're going to have to pair up the vision with the sound and all that kind of stuff. And then these cells are going to have to grow to form this machinery that the information will eventually flow through in a developed adult. So it appears, for whatever reason, that hasn't developed correctly, and so we kind of run into this issue of timing, which is, if the timing is off for whatever reason, in the child during their development, the cells may not develop correctly, and the messaging will be off, and then you may end up with an underdeveloped region in the brain, which maybe handles certain kinds of messaging. So, if one thinks of a human being as having a brain, and there's a certain parts of the brain that process messages, and that those parts are underdeveloped, all right, which appears to be the case in autism, then obviously that's going to have an impact on the child. So so the idea here is, having done some limited research, it's a very big topic. It's very complicated, and it's obviously you have to be very sensitive to what you say about it, because you can get it wrong so easily. Um, but the basic idea is that, let's just assume you have a architecture that's message based, and you have a system consciousness, and you have inflows and outflows of messages, and some of those messages are simple things like goal based messages, like make a friend, or or kind of relate to somebody in a particularly emotional way. And the idea would be, if you, or you might say, taking information from down from a board and listen to the teacher visual and auditory messaging, and somehow you have an immature section of the brain to do with that. So you might see, so the idea is pretty simple. If you've got, let's say, an audio and a visual feed going into your brain, and it's a message based, and your brain isn't properly synchronizing the two message types. So, in other words, if you imagine a movie where the soundtrack is just off from the picture, eventually you'll just switch off the sound. You won't, you'll turn it off. So, basically, it appears in some cases, some autistic children have huge problems with sound. So, it kind of would indicate that maybe some of the message centers for sound aren't properly synchronized with vision, and causes a huge degree of stress on the child, and they zone out on auditory cues, which is a normal, and human beings normally, use a lot of auditory cues to kind of talk to each other. So you could see someone maybe, not getting hearing, but not processing the sounds, zoning them out. So we start to think of an architecture where it's really important that the messages that come into the body are properly balanced. So that's kind of what I'm trying to get to here. So think of an autistic person as someone who is functioning normally, but that their messaging in their brain is just not properly operating due to maybe some undeveloped section of the brain, or or a timing issue between the message types. So so that can cause a lot of issues in terms of the ability to process information correctly. Um, so so that's kind of where I'm coming from with this whole autism idea, balancing the messages and processing them in a way, pairing them, and these, in other words, imagine if you had a machine, you created an android and you took in audio messages and video messages, and there was a problem with the central processing area, which might be near the cerebellum, and it just isn't working right, and you're talking to an android or a machine, and it's getting the pictures are out of sync with the sound. So basically, that could completely disorient the machine. So imagine a human being whose body is supposed to sync up sound and vision, and it can't do it. Or if it's to do with emotional messaging that isn't coming through properly, and it can't, and the person can't properly read facial expressions, or so if the messaging gets messed up, then in the brain, then it can cause huge issues for the child or the adult. So then we move on next to the idea of competing messages and goals. And this builds on the idea, okay, let's assume that we're dealing with a being that where the messaging is correct and it is being properly synchronized and so on. You might it's not, you can have two separate goals. You can have two separate messages trying to achieve different goals. So basically, one message might be, I'm hungry, so I need to make a sandwich, versus I see a tiger approaching and I need to run. So clearly, we all know survival outweighs having a sandwich when a tiger is attacking you. Nobody needs to be told that. So once you say the words tiger attacking, in your brain that maps to a survival type scenario. In other words, it's the end of your being. So you can go hungry, if initially. So the basic idea is that in our brain there will be messages that will come in, and they will have different priorities, and there maybe even messages that come in to try and satisfy the same goal. So part of this architecture would have got certain messages competing for the same goal, and then you'd have two messages for two different goals, and then the goals compete with each other. So we move into this kind of message architecture in the brain where you're balancing your goals against your messages. So this is pretty important stuff, but I just want to give you the idea of the concept. And this is different from autism in that in the autistic case, the messaging itself might not be functioning correctly and causing a lot of problems in trying to interpret what's going on. So I talk a little bit more about competing goals and messages, and then we come on to a really important topic, and I'll move on to that in the next chapter. But it's acupuncture, and you might think acupuncture is kind of like nothing to do with an Android design, and like why would you care even about acupuncture in an Android design? You're not going to give an Android acupuncture. Okay, so but the point is, what does acupuncture give a human being, right? And here's the idea. It's pretty simple. If you read up on acupuncture, one of the things that they found in the East, in places like China and so on, is if you suffer a certain kind of a pain, they have mapped out the body in such a way that they know that if you insert a needle into a particular region of the body, you get a reaction in another part of the brain, which maps to another part of your body. So, for example, studies have shown you can you can relieve a hip pain by inserting a needle into a certain part of the body. And the people in the East, in China and places like that, they've worked it all out. They've body mapped a human being, and they know where everything, what connects with what. So how does that work with this idea? It's pretty simple. These zones produce messages of a particular type and of a higher priority. So in other words, if you give acupuncture to someone in a particular part of their body, and they get pain relief, what that really is telling you is that the messages that you're getting from that region that has been stimulated by the needles, that messaging has a higher priority in your system consciousness, in your brain, than the messaging coming in to regard to pain. So in other words, it can alleviate pain, but it has to override the messaging. So the brain architecture has mappings, and certain regions overlap in terms of the message mappings, and you can override pain. You can relieve pain by creating messages when you put a needle into a person's body at a certain point, and then those messages go up into the brain and they override the pain messages. For example, that's just a simple example. So that's the idea, and this is where we start thinking of fine tuning an Android, where maybe if the Android is malfunctioning, we might have the ability to override the message types that go into the Android. Let's say there's a faulty sensor in one part of the Android, you might have the ability to override, instead of replacing the unit, you just override the unit's messaging with another set of messaging with a higher priority, and you block it out rather than have to go in and crack open the unit and replace it as some malfunctioning thing and or disconnect it. You just override the messaging, and that's it. Pretty simple. So here we have a human being. We start to think about all the messaging. We start to think of all the kinds of problems people experience. We've autism, we've acupuncture, we have all these different scenarios I've talked about. So we start to kind of begin to build a picture of a human being in kind of messaging terms, and how we can start to take advantage of that in an Android architecture, and what things to watch out for.